Now this is the 7th chapter, that is morphological image processing. These are the contents that we are going to look into in this chapter. So to basically start with, what is morphological image processing? This is a set of non-linear image processing operations that we are going to perform. So as per Wikipedia, the definition goes like this. It only depends on certain specific ordering of the values of the pixel and not the numerical values within. So what does this mean? That you may not understand right now, but as we go ahead you will understand it. Okay. Now morphological operations can also be used in grayscale images. We are going to see them for both binary images also, grayscale images also. Binary images are nothing but jahan pe only 0 and 1 black and white values are there. Now basically in all of the morphological operations that we are going to see, we are going to evaluate an image called as structural element with a small shape or template, and this structural element is placed anywhere in the image and we are comparing the structural element with our image pixels. Okay, and then we have either fit, hit, or we have miss. Okay, if it is fitting exactly as it is fitting, then it is a fit. If it is fitting at one place or two places, then it is a hit. It is just intersecting, it is not as it is. And if it is neither fit nor hit, then it is a miss completely. So ये जो hit and miss and fit है, ये क्या है exactly, that we will try and understand now. It is a very simple concept, but an important concept. You should understand it right now only, so that you understand rest of the things that I teach you. So this bigger rectangle is my image, and each of the square that you can see in this rectangle is the pixel. Okay, now as I told you, your structuring element is going to be a small element. So कभी 4x4 sorry कभी 2x2 या 3x3 ऐसा आपका structuring element होता है. So this is your structuring element, and as you can see, all the 4 pixels of structuring element, let us say that they have the value of 1. Okay. So gray color value is non-zero. I am assuming it to be 1. Okay. So if I place this element, imagine this structuring element, move it and place it over here. Can you see the green color that I am drawing? Yes. So I am going to point to the pixel and you have to tell me, is it a hit there or it is a miss there? Is it a hit over here? No. Because here the color is white, here the color is grey. So is the color matching? The answer is no. What about this pixel? Again the things are not matching. What about this pixel? Yes, they are matching over here. Now out of 4, 2 are not matching and 2 are matching. So obviously this is not a fit, but this is a hit. Okay, so such a situation is called as a hit. Similarly, if you see the B part, it is also a hit. Why it is a hit? Because ये gray and ये gray match कर जाएगा. But if I see the C part, you will understand कि all these 4 pixels are white and here all my 4 pixels are gray. So none of them is matching. So it is a complete mismatch. Okay, so it is neither fit nor hit. Whereas A, it is a fit. Why is it a fit? All 4 are 1, 1, 1. Okay. This is the concept of hit. If there is an intersection, 1, 2 or 3 are matching, but all are not matching, then it is a hit. If all are matching, then it is a fit. And if nothing is matching, then it is neither a hit nor a fit. So the structuring element neither fits nor hits the image. Here the structuring element fits the image. Here the structuring element hits the image because there is an intersection. Here also structuring element hits the image because there is an intersection. 2 जगह पे हो रहा है, 2 जगह पे नहीं हो रहा है. So the morphological operation on the binary image will produce a new binary image with a pixel value which is not 0 only, if the test at the location in the input image is successful. Now, which test are we talking about? The hit and fit test that we are talking about. Now, the small binary image is nothing but it is your structuring element. It is a small matrix of pixel, each with its own 0 or 1 value. अभी यहाँ पे structuring element में all the values were 1. But is it mandatory that every time a structuring element is going to have all ones in it? No. For different operations, we are going to need different structuring elements. Okay. Now, sizes of the structuring element indicates the matrix dimension. I already told you कि we don't have only 2 by 2 structuring element. You may have a 3 by 3 structuring element also. Okay. The pattern and the zeros specify the structuring element shape. What is the shape of the structuring element? Is it square? Is it round? What shape it is, that is decided by the pattern of zeros and ones. Okay. Now, one of its pixel typically originates from the structuring element, but the origin could usually be outside the structuring element also. What does this mean? If you see different structuring elements, okay, I told you na, structuring element can have different sizes also and they can have different shapes also, and not all structuring elements need to be all ones, correct? So you can see in the first 3 structuring elements there are zeros also. Okay. Now, every structuring element can have its origin. It can be one of the pixel in the structuring element also, or it can be outside the structuring element also. So here, wherever pink color pixel you are able to see, that is considered as the origin. Okay. Now, quickly let us understand what is the shape of the structuring element. Now, if you look over here, this is all ones. So the shape is square. If you look at ones over here, and if I try to join all the ones, what do I get? What is this shape? Is it a diamond? So what is the shape of this structuring element? It is a diamond shape. यहाँ पे अगर मैंने ones को connect करने की कोशिश की तो क्या मिलेगा मुझे? Cross. So this is a cross shaped structuring element, and this is again a square shaped structuring element. Now, whenever your structuring element or structuring matrix has odd dimensions. Odd dimensions means what? 3 by 3, 5 by 5, 7 by 7, 1 by 1. All these are odd dimensions. 2 by 2, 4 by 4. These are even dimensions. So usually जब odd dimensions होते हैं structuring element के, so जो center of the matrix होता है, that can be also considered as the origin. Okay. So in morphological images, structuring element plays the same role in the linear image filtering as convolution kernels. Now, in case you remember, I had taught you something called as median filter and average filter या mean filter, correct? We had applied the filter across the images. So वो जो process था, that process is called as convolution. Okay? So वहाँ पे जैसे फिल्टर या कर्नल का काम होता है, वैसे ही यहाँ पर morphological operations में you have structuring element. Okay. Now, if a structuring element is positioned in a binary image, each image of the structuring element is associated with the corresponding pixel of the neighborhood. Neighborhood किसका? Image का. अभी ये देखो. I have a structuring element S1. And another structuring element is S2. Let us first consider S1. Okay. Take S1 and make it fit over B. Can you see B over here? Is the outline clear? Yes. So make it fit over B, and now you will tell me, is it a fit? Is it a hit? What is the situation? S1 is all ones. Does B have all ones? The answer is no. So S1 and B is not a fit, but yes, it is a hit, because rest of the elements, they are matching. Okay. So for hit, you want that at least one position intersects. So see C. C may, if I try and place S2 over here, S2 is cross, correct? So S2 and C is neither fit nor hit, because when fit happens when all the positions are matching. जैसे B and S2 is a fit. B and S2 is a fit. So it is a hit also, it is a fit also. But S1 and B is not a fit. Why it is not a fit? Because this one position is not matching. So it cannot be a fit. But it is a hit because there is some kind of intersection happening there. Okay. So this is a very basic, very minimal concept. So basically, erosion and dilation, they are opposite of each other. So dilation, if it is expanding the image, erosion, it is going to shrink it. Okay. Now, how the image is shrunken? Kitna shrinkage ho raha hai, that depends on your structural element. Okay. Now, structural element is smaller than your image itself. And generally, uska size 3/3 hota hai. Okay. Why this is done? Because agar structural element बहुत बड़ा है, then the computation will take more time. ठीक है? Now erosion as well as dilation में आपका structural element जो है वो left to right and then top to bottom ऐसे you have to move it across the image. Okay? Now you check whether there is a complete overlap or no. If no complete overlap happens, then the center pixel given by the structural element center will either be set to white or 0. Please remember, many a times we all work with the conception that white is 1 and black is 0, but in our case white is 0. Okay. Let us assume that X is our image. Okay, binary image. Binary means what? Black and white. Binary means what? Black and white. Only two colors are there. And B is our structuring element. B is our structuring element. So how is the erosion given? The outcome element Z is only evaluated if the structuring element is a subset of or equal to the binary picture X. Okay. Now, how does this actually work? Okay, before I go there, we are supposed to remember this symbol of erosion. It is a circle and there is a minus sign in the circle. Extremely important to remember this convention, because we are going to need this convention later on at lots and lots of places. Okay. Now, let us quickly see this. This is my structuring element. Okay. Can anyone tell me the shape of this structuring element? What is the shape of this structuring element? It is a cross sign. It is a cross sign. And where is the center? This is the center. Okay. So if you place this structuring element over here, is there going to be any kind of match? No. So your pixel will be of which color? White color. Now you place your structuring element over here. Is it going to match completely? So what happens? Complete overlap is there at this position. The answer is no. If I place it like this at this position, there is no complete overlap. These two pixels which are supposed to be black are white. So what we will do? ये जो double dot वाला pixel आपको दिख रहा है, that will be converted to white color, as you can see over here. But now what happens when it moves to the next pixel? Let me just erase all these markings. What happens when I place the structuring element over here? Is it a complete overlap? Yes. So this 3 dot wala pixel, it will remain what? Black. It will remain what? Black. It will not change to white. Okay. Remember, complete overlap is there. Don't change to white. Complete overlap is not there. Change it to white. Now, dilation is also done in the same way. Dilation में क्या होता है? Again, you know the size and everything of the structuring element, just as we had discussed in erosion, exactly same points are there, so I am not repeating it. Again, dilation may be left to right, top to bottom, you are supposed to shift it. overlapping pixels are identical, then you keep it black or 1, and if they are not identical, if the overlapping is not complete, then you make it 0 or white. So whatever was there in erosion, these things, they are same in dilation also. There's no change. What changes? The symbol changes, because the concept of dilation is completely opposite of what is there in erosion. So how is the equation defined? X, in a circle there's a plus sign B. Again, X is the image, B is the structuring element. Okay. Now, this B cap, can you see? What is the meaning of this B cap? You are rotating the image B, whatever is your structuring element, you are rotating it about the origin. Okay, I have already told you about the origin of the structuring element. Okay, so that concept I am assuming ki you know. Okay. So the outcome element Z is that at least one element in B intersects with an element in X. So at least one intersection has to be there. The position of the structural element within the image will be set to on. This procedure is depicted over here. Now let us see this procedure. Now place your structuring element over here. Is there any kind of overlap? No. Partial overlap is also not there. I place my element over here. Is there any kind of overlap? Yes. Are you getting it? So whatever is the position over, whatever is the pixel at this particular position, it will be turned to black color. So can you see this pixel position has turned to black color? Let us take one more example. I am just erasing what I have done till now. Let us keep the structuring element over here. 1, 2 and 3 pixels, they are overlapping. Yes, now this is my structuring element, correct? If I place this cross over here, 3 pixels are overlapping. You convert this pixel to black color. You can see the conversion of the pixel to black color. Now you can understand that the dilated image is a superset of your input image. It has expanded your input image, whereas the eroded image is always the subset of your input image. Okay, this is what you are supposed to keep in mind. So dilation operator is an enlargement operator. It will increase the size of your image. Not in terms of pixels, हाँ, और मतलब ऐसा नहीं कि अभी 10 by 10 image है तो 20 by 20 हो जाएगा, ऐसे नहीं. The boundaries will be enlarged. उस terms में I am telling you. Okay. Now why dilation is used? आपको कभी gaps bridge करना है, कुछ components disconnected दिख रहे हैं, उनको connect करना है. Then in that case, dilation can be used. Now just as we have erosion and dilation, similarly we have two other operations which are opposite of each other, and they are opening and closing. Okay, now opening and closing are the operations which are eventually explained in terms of erosion and dilation only, and that's the reason I told you we need to remember the signs of erosion and dilation. I'll revise again. Erosion signature is shown like this, circle and a minus sign inside it, and dilation is shown as circle and plus sign inside it. Okay. Please remember, this signature is intersection. This signature is intersection. This sign is belongs to. Okay, these are basic mathematics signs, so I did not tell you earlier, but in case anyone wants it, this is the meaning of the signature or the sign. Signature nahi, of the signs. Okay, so understand that just as erosion and dilation are opposite of each other, similarly opening and closing is also opposite of each other. Okay. and opening and closing are eventually defined in terms of erosion and dilation only. Okay. Now opening of image A by B. So B again here is your structural element only. So how is opening written? A opening B is shown by a circle which is not filled. Okay, please remember how opening is shown. We are going to need it later on. Now, see the sign of opening first of all. I hope that is very clear. Now, what is the formula for opening? I have told you many times that opening and closing both are expressed in terms of erosion and dilation only. Again, revise the sign of erosion and dilation. See, this is erosion, this is dilation. So, what will I write? A eroded by B, dilated by B. Okay. Now, the functional symbol for opening is gamma BA. Okay, this is also another way of writing it. Another formula for writing A opening B is, it is a union of, this sign is union. I told you this sign is intersection, this sign is union. Remember your set theory, same methods come, same meaning will be used here also for intersection and union. Okay. The opening is determined in this case by union of all translations of the structural element that fit within the input image. So you're moving your structural elements across your input image, जहाँ जहाँ पर fit हो रहा है उस सबका union ले लो. Okay. Each fit is identified and the opening is determined by adding the translations of the structural element to each identified locations. And this is exactly what eroding and then dilating refers to. पहले erosion करो, उसके बाद जो भी result आता है उसका dilation करो. Okay. In case you guys remember what I had told you earlier, कि your structural element or your structuring element need not be every time a square or a cross or a diamond. It can be circle also. So here how is your structuring element shown as? It is shown as a circle. This is your input image. When you erode this image, what happens? This is what happens and this is what you get. The image is eroded, the image is shrunken. Correct? Now you are opening it. But is your structuring element square? No, it is a circle. Correct? So जब ये eroded image को आप dilate करोगे, तो you will get rounded corners. Are you getting it? Why these rounded corners are there? These rounded corners are there because your structuring element is circle. Okay? Now, go. So, union is this symbol U and intersection is like N symbol. So, opening is determined by union of all the translations of the structural element that fit within your input image. So what you are going to do is you are going to take your structural element and you are going to move it across your entire image, and wherever the fit occurs, that you are going to take union of all those translations. Okay, this is exactly the same result that we get by eroding the image first with B and then dilating the result. Okay, so every time the structural element need not be a square or a cross or a diamond. You can have a structuring element which is a circle or a oval also. Now let us see, when the structuring element is circle and your input image is a rectangle, what happens? सबसे पहले you erode this input image. Now when you are eroding it, you will get a rectangle only but smaller in size, as you can see the difference between figure B and C. Now what happens when you are dilating this image C? Erosion के बाद dilation करना है ना? So when you are dilating this image C, what happens is, because your structuring element or structural element is a circle, you get rounded squares like this. So after opening, this is what is going to your, this is your result. Okay. Now similarly, let us take another example. Your structuring element is a circle only. Okay, your input image is like this. You can see what type of image is this. You're performing an opening operation, this is what you get. And if you are performing an operation which is called as opening top hat, as of now we do not know what opening top hat is. But if we perform something which is called as opening top hat, this is what we are going to get. Now let us try and understand what opening top hat means. Now, if we say that we are subtracting the opening from the input image using the set theory, then this operation is called as opening top hat. So the concept of opening top hat is very simple. You subtract your opened image. This is your opening image. You subtract it from the original image. Okay. So when you subtract it from the original image, this part will vanish. Yes. So what is going to remain? Only the small triangles which are there around the border. So this inner shape, it will go away. So again I repeat, how do I get the opening top hat operation? By subtracting the opening image from the input image using the set theory. Okay, so it is a very simple concept. Okay, now opening top hat का application कहाँ पर है? To detect the gear teeth. So whenever you know there are certain spikes and you want to know the spikes, you want to check whether the spikes are correct or no, gear teeth are correct or no, then in that case opening top hat can easily be used. Okay. Now what we saw was opening. Similarly, what do we have? Closing. So how does closing work? First of all, what is the sign for closing? It is a circle, but it is a filled circle. Opening का sign क्या था? Circle ही था, but it was not filled. Here closing का sign is a filled small circle. Again, I remind you, what is the sign of erosion? A circle and minus sign in it. What is the sign of dilation? A circle and plus sign in it is the sign of dilation. Okay. So closing is a complementary operation to the opening, which can be described as dilation followed by erosion. So पहले A dilation B, whatever is the answer of this, you eroded by B. Okay. In the functional notation, how is closing denoted? This is how closing is denoted. Okay. Circle is your structural element. This is your input image. When you dilate it, this is what you get. See, ऊपर भी जब dilation किया था, then also you had got these rounded edges, correct? So here also you're getting rounded edges in the dilation, and then closing. इसको जब आप erode करोगे, remember you are eroding again with a circle. So here तो you get the sharp edge, but you get a small circular shape over here like this. Okay. So this is the output of your closing operation, which is dilation followed by erosion. Now as I told you, there's a closing and opening, they are opposite of each other. So how can we show it? A closing B is equal to A complement opening B, the whole complement. Okay, and exactly in the same way you can write for opening also. A opening B is equal to A complement into B closing C complement. Now you must be wondering, everywhere on top of B sometimes there is a cap like sign. What does it mean? You can have a B element and it has to be rotated around the origin. Okay. Now if B is symmetric in nature, then the rotation will give you the same answer. If you rotate it by 90 degrees and it is symmetric, and you get the same answer. If it is not symmetrical, then obviously the rotation is going to change the shape of change your structuring element. Okay. Now जैसे opening top hat था, वैसे closing top hat होने वाला है. Okay, so what we are going to do? We are going to subtract the input image from the closing answer, which yields the closing top hat. So exactly जैसे opening top hat था, exactly in same way you have a closing top hat. Okay. So as I told you कि every time it is not necessary that your structuring element has to be symmetrical. In case your structuring element is like this, then B and B cap are going to be two different things. Till now we were looking at only symmetrical structuring elements. So B or B cap, they were not making any difference for us as such. But here when I am using B and when I am using B which is asymmetrical, which is non-symmetrical, then obviously B and B cap are going to be different. Okay, at many places the cap is written like this. Small shape is there on top of B. You can just replace it by this symbol, a cap. Okay, and you can see how what difference it is making. Observe this. Many a times closing top hat operation is used for character recognition. So one application of the closing top hat operation is for character recognition. You can see the input image. You can see closing by a disk. Disk is nothing but a small circle. And then you can see the closing top hat operation. This is another example where your input image is there, structuring element is there, okay, and opening operation is there and closing operation is there. Okay, you can see that whatever gap is there over here, that gap is actually, it is closed in the closing operation. Whereas if you see, this is a very thin line. In opening operation, that thin line vanishes. Okay, so जो भी ब्रिज होगा 1 पिक्सल लेंथ का वो वैनिश हो जाएगा when you are opening it, and जो भी 1 पिक्सल लेंथ का गैप होगा वो गैप कवर अप हो जाएगा when you are closing it. Now how can I say that 1 पिक्सल लेंथ का ही गैप क्लोज होगा क्लोजिंग में, या 1 पिक्सल लेंथ का कोई लाइन है तो वो लाइन चला जाएगा ओपनिंग में? How can I say this? Because can you see only 1 pixel is colored over here? Yes, in your structuring element, can you see only 1 pixel is colored? Had it been 2 pixel size, then जो भी 2 pixel के lines है, 2 pixel length के lines है, वो सारे lines हट जाते इस G symbol से opening में. So it all depends on your structuring element. I hope you are getting the concept.